Hello, everyone, and welcome to our Flowable Performance Mastery presentation for this FlowFest this year. I'm Filip Hrisafov, and together with me, I have my friend and colleague Joram Barrez.
Yeah.
We've been both working for Flowable for more than 7 years, and Joram has been more than 16 years working in the BPM field, basically.
That's an old way of saying I'm an old man, Filip.
Behind the scenes, we also have Bert. He's gathering your questions from the chat, so feel free to ask any questions during the presentation. At the end, we're going to go through them, and Bert will help us answer the questions.
Give him lots of work, please.
Yes, please. So during this presentation, we are going to talk about some fundamentals for Flowable. We're going to talk about some performance practices, how you can apply certain things and do certain things for Flowable. Then we're going to go to the measure section, basically how you can actually see when you need to do certain things. And then we'll wrap it up and head to the QA.
I'll leave you
now.
Yeah, thanks, Filip. Yeah, so basically we need to get some fundamentals in our head, some concepts, which we're going to talk about throughout the presentation. So let's just, get these together in our head so we're talking about the same thing. So first of all, Flowable is a software platform where you can build new software. You can build orchestrations, automations, and there's a variety of ways of how you can deploy Flowable, meaning you can run it standalone, which I mean a jar or a war. You can run Docker, you can use Kubernetes, you can build a custom Spring Boot project. And we try to ship those with sensible defaults, which means that we try to make those defaults to work on all these kind of sensible default way. But of course, if you have to scale out, and this is a good problem to have, it means that the software you're building is getting popular, then you need strategies to ensure smooth operation. That's exactly what we're going to talk about today. So why is it us two geezers here talking about this today? As Filip said, we've got many years of experience building high scalable, high throughput engines, and we work daily with over 100 customers, many large corporations that have high demands on complexity, on scalability, and performance. And that's why we've got lots of experience to cover this particular topic. Now, if you look at Flowable again from a high-level kind of architectural point of view, we've got the instances, and they go against a relational database. Inside of Flowable Work, there are the engines that we just talked about. They're embedded inside. And you have the optional indexing, the kind of storage of data into Elasticsearch for kind of dashboard queries and all of that. And we'll talk about indexing more later on. Now, the first question that many people ask is that, why do you use it? Isn't there anything new, fancy on the market that would be better? And it's true, relational databases, I think the first version of a database or relation database, I think, was in the middle of the 70s. They're quite old, but they remain crucial up to this day for large corporations that want to do mission-critical workloads. And try to remember that the databases of today, they resemble in no way their grandparents of the past decades. They have evolved, technology has evolved, engineering has evolved, and they don't look alike at all. There's two things that are the same still, though. That's SQL, and I'm a really big fan of SQL for the simple reason is that it's based on solid mathematics. And if there's one thing that you can't argue, mathematics. And the second thing, and this is really important for Flowable, is transactions and assets, atomicity, consistency, isolation, and durability. That's the stuff that we build upon to guarantee certain things in Flowable. Now, businesses, they often reason in those transactions. When we talk about transactions, we sometimes mean technical transactions, but the word is you're giving something in return for something else when doing a deal, for example. Now, the problem is that computer systems, they are not atomic. They have network problems. They have problems with heating. A disk can crash, and there's even cosmic radiation you have to take into account. And this is not a joke. There's a little link I put there on the slide, is that if you check that vendors, hard disk vendors, they actually need to take into account that cosmic radiation, it can flip a bit and it can change your data. So they have to take into account and do some kind of checksums on all of that. So by building on the foundations of the relational databases, we rely on the fact that the databases handle all these nasty problems for us. And we believe we do best, which is building high performance, high scalable engines. And we don't need to reinvent the wheel. We don't need to implement transactions ourselves or compensations ourselves. Now, this is not just us saying that because we chose relational databases. This is a famous paper. I think it's 2 or 3 months old. It's called What Goes Around Comes Around, and there's a link. It's from 2 professors, one from MIT and one from Carnegie Mellon. This is actually the sequel to the first paper, which is 20 years old. And they looked at what happened in those 2 decades since that first paper. And they looked at all the things that happened, the whole NoSQL movement, the whole MapReduce, and everything else. Really interesting paper. And one thing at the to just read out loud, because I think it kind of captures well what we're trying to say, is they say, and I quote, "Another wave of developers will claim that SQL and the relational model are insufficient for emerging application domains. People will then propose new query languages and data models to overcome these problems. There is tremendous value in exploring new ideas and concepts for database management systems." It's where they get the new features from SQL. They say, but it's true. I mean, there's examples like the JSON and the full text JSON searching and all of that of recent years. However, they say, we do not expect that these data models do supplant the relational model. If you're interested in that, go and check that paper. It's a really good thing, and it kind of vibes with what we are saying. All right. Execute, a really important kind of component in Flowable. It's responsible for executing things in the background. It allows you to handle more things concurrently without having to wait on them. You distribute the workload across your Flowable instances, and if you have a failure, stuff gets rolled back automatically by using the transactions. Now, one thing that we focus a lot on Flowable, or we build logic into Flowable, is the network round trip. We really try to squeeze in as much as possible into one network round trip. Computers these days are extremely fast, but in the end, they're limited by the laws of physics, by the real world, meaning electricity or light can only travel as second as physically possible. If you're interested in that, or if you Google latency numbers, every programmer should know, famous thing for developers, you will get some ideas about the relative kind of magnitude of order that it goes between local execution and a network execution. And just to give you the kind of relative kind of things here, if CPU cycle, and you say one CPU cycle is like clapping your hands, it takes like a second, then reading 1 megabyte from your hard disk is the same, relatively again to that clapping of your hands, to 17 days. In 70 days, I can plant and harvest a zucchini. Well, I can't because I have no clue how to do it, but people can. And if you then look at the REST call over the internet, that's 7 to 8 years relatively towards that clapping of your hands. In 7 to 8 years, you can get a master's and PhD if you're studying very hard in that. Just to give you some ideas about the magnitudes that are playing here, and that is why we really focus hard on the network round trip at Flowable. Okay, so we got the concepts all in our heads. Let's talk about the practices when it comes to performance. The obvious first thing is system resources. Always, when we talk about any of these kind of challenges, we look at hardware, right? We designed Flowable to run efficiently on even limited hardware. And for many of those use cases, it works very well on those setups. But if you need to scale out, and again, a good problem to have, it means your software is getting, it means more custom logic, perhaps, more logic in general, and definitely more data, instances, variables, and all these kind of things. And upgrading these system resources is almost always gives you better throughput. For the database, for sure, if you give it better hardware, it will give you better throughput just by the nature of having better hardware. For Flowable, it depends. Building models, processes, for example, with lots of CPU-bound logic, yeah, then it's going to help if you add more CPUs. For example, if you keep a lot of things in memory, it's going to, I mean, these things are just natural kind of software engineering practices, right? I do want to kind of call out Kubernetes here, because in Kubernetes, it's pretty much trivial to kind of get a node down, boot over. But system resources, the kind of hardware you give to the whole cluster of your Kubernetes pods, is still important. Just a simple example, if you have 4 pods with 2 gigabytes of RAM, that typically will have less throughput, less scalability than 2 pods with 4 gigabytes of RAM, which is kind of counterintuitive. But the way that a virtual machine works, the way that the network round trips, again, work, that's simply how it works. That's, don't try to run on the shoestring, just give it some decent hardware and don't worry about, some optimization that might cost way more money than just giving it hardware. And this is an example of a recent job, a benchmark that we did. Now, the actual benchmark is not that important. I mean, we're testing some no-op things here. You see like up to 250,000 jobs per minute for these nodes. But I made a mistake. I clicked through the whole wizards in AWS, and I wanted to have a C5a X large machine, but I didn't click the configuration of the machines, and I got a micro. And you see here, even though the micro has already good kind of numbers, you see 50 jobs per minute for this benchmark, you see the difference between that micro and a decent machine. I think that machine has like 32 or 64 cores or something like that. Again, we didn't optimize at all here for this particular use case, but just to give you an idea of what we're talking about. When we talk about network, there was another mistake that I made, and yeah, it's good that I made a mistake in the presentation, is matters. So I booted up 4 same machines, same Flowable instances, same data center, all of them running in Frankfurt, I believe, on AWS. But for some reason, they hide the subnet behind some advanced configuration, and they were running in different availability zones. And you can see that I have 3 different availability zones for these 4 machines. You can see the 2 machines availability zone, yeah, they were really the same kind of numbers. The green one was actually the one that was in the same availability zone as a database, because the network round trip simply was faster. So those things, they do matter. So Philip, you wanted to say a few words about data and all these things, right?
Yes, that's true. Yeah. So we see how system resources can affect the performance, right? However, data also does affect these things, right? So executing orchestrations in Flowable generates a lot of data, and generating a lot of data leads to storing a lot of data, right? And simply said, the more data that you store, the more work the database will have to do, right? And we do have some practices for this. So we have some indices, we have some, not just some, we have quite a lot of indices on the database so that we can query the data appropriately. But however, it's still important to keep an eye on the row counts and the table sizes that you have in your system, right? And it's actually can be way more than you think. We've seen customers which are having more than 1.4 terabytes of data in a database, right? So that's why it's really important to manage this data. And how to do that, there are a few ways. So one way is to use the history levels that we have. So with the history level, you can actually choose do not store any historic data to store as much as possible, right? To store basically everything. And this has a huge amount of impact on the amount of data stored, right? Because it means it stores less data if you need to store less data in the history, right? And the way that you can configure this, you can either do this globally for all the instances, case and process instances, or if you want, you can even do it per model. So you can say, okay, this model is my straight through throughput model. I don't really need any auditing for this, and I will not store any historic data. So only the runtime data will be stored. And when the process is done, that data is gone from the database. Then another thing that you can do is do housekeeping. So we have out-of-the-box housekeeping that you can configure, and it will basically run every day and clean up data older than let's say 1 year, right? Everything that has been completed, it will clean it up. However, you can also model this. So if you have some more advanced use cases, you can use the housekeeping task in design, and you can model this and configure how you want to basically do the housekeeping for your custom processes and cases. And then variables. Variables deserve a really special mention. So when you're doing some orchestration, you always have some variables that you store in your system, right? And they can come from different places. They can come from the forums, they can come from external data sources, your own services, and so on, right? And housekeeping and history level also has an impact here, because you can choose what you want to store, which variables you want to put them in the history tables, or once the housekeeping runs, it deletes the historic data and does the variables, right? However, what you could do is you could look into using transient variables. And this means that, for example, at this example here and below, we have a service call, right? So the service call does a REST call, and it's going to have some variables in there. We can store the response in a transient variable, do some enrichment of this data, extract the data that we need, and only store a subset of this original data as an actual variable, which will be stored in the database, and then display this. So with this, you're reducing the amount of data which will get persisted in the system for Flowable. Another approach that is really important for Flowable is the indexing, right? So here we have processes and cases data. This data, whenever a process something gets changed in the process or a case, this data is sent to Elasticsearch which is their index, and then it's later on used for dashboards and queries. The way that this is done asynchronously by a dedicated async executor. So it does not slow down your existing transaction, but it's done behind the scenes. And the relational database stays as the main source of truth. So this means that if you need, you can drop your Elasticsearch data, remove everything from there, and then re-index all the data fresh from what you have in the database. And what is really important for this is to keep the hierarchy depth, which means like how many child cases and processes you have in your structure, under control. Because if your hierarchy is quite deep, you will be indexing a lot of data, basically. And what you also need to think about is the variables. So how big are the variables which you are storing? Because let's say if you have a root variable, that variable gets stored also in the children. So yeah, you have to make sure and also be aware of what you're storing in the index. Luckily, now we have that large variables are no longer indexed. So if you have really large variables, they will not be indexed by default. If you need that, you can still enable it, but by default, it is disabled. So
it's a constant choice now, right? So you need to really. This is regular software engineering. Even if you would write regular programs, those things apply, right? Your variables, your sizes and frequency and stuff like that.
Indeed. Yeah. Some other things which also impact performance is the external services. So an orchestration is rarely exists in isolation, right? So you always, user fills in a form, you need to do something with the data, let's say called a third-party REST service, and process this. And while this service is happening, the user is basically waiting on the response, and the transaction is open until the next wait state. So if we take the example here below, we have a user filling in a form. Once the form is completed, we go to the external service call. And because everything is happening in one transaction synchronously, the user will be waiting on the response of the service call until we reach the next wait state, which is the next user task. And this can be like, this can take 200 milliseconds, or maybe can even take 1 second. It really depends. So one good thing to do here would be to make async. So to make the service calls async. What does this mean? This means that the wait state actually becomes the service call. So the user fills in the form, they complete. Flowable is going to create an async job and return the control to the user, which means there's now the user can do some other work, not related to this process, but some other processes. And then when the service is done, it's going to create the other user task that the user can continue working with this process.
Yeah, and the dotted line there, I think Filip is also indicating that you can do it at entry or also at exit, right? So you're free to kind of decide when you want to cut, or both, right? When you want to cut up the transaction and do things asynchronously. Indeed.
Exactly, that's a good point indeed. And another approach that you could do is to basically use the external worker pattern. So this is different. This is similar but different to async jobs. So basically, what happens here is the external worker task is the wait state, right? It stops. But however, Flowable doesn't do anything at this point. Flowable just says, okay, we have this work ready, right? The external system is then polling Flowable on its own pace, deciding, okay, how busy it is and what it needs to do. It's polling Flowable to see if it has work for it. If there is work, Flowable will lock the task, will give it to the external system, which can then process the data, and then through the API complete that task. Once that's completed, the control goes back to the process and continues to the next user task, which is showing the results to the user here at this case.
Another benefit is that the external system can be in any language. We've got client libraries for Python, of course, for Java, for JavaScript, and you can, whatever you fancy, you can just write that if you want to. In the end, it's REST APIs, but we made some client libraries to make this easier for you. Right? Just go to our GitHub page and you will find them.
That's correct, yes.
And I talked already about the async executor. And there's a few things, as Filip is telling you, it's an important component to do things in the background. First thing is quite silly, but we want to stress it out again because we've seen many mistakes in the past. If you configure the thread pool, put the core and the max size to the same value. There is weird JVM, JDK behavior here. They're really not as you expect them to be. Just trust us, put them on the same value. We will auto-scale this pool for you. Another thing is, don't be afraid to use large values here. We've seen people really trying to get with 2 threads, 4 threads, whatever. Don't worry about these things. If you install Tomcat, for example, by default, it has 200 threads, or you can go threats if needed. Same with Flowable. It will auto scale depending on your needs. The only thing you need to take into account with Flowable is you need to configure your connection pool accordingly. You need to make sure that every thread in the thread pool can have one database connection, because we do that in one transaction to roll back afterwards. And this is a segue to the next part, is you monitor these things. You do want to monitor the threads, the queue sizes, the queue being the part where we put the jobs on to take work from, and we want to monitor the execution times in our system. Now, this is again from that benchmark. Just to give you some rough ideas, I know the numbers are readable, but I'll just tell you them. This was using AWS, a really beefy 4 Flowable nodes. And basically no op, no history, kind of no variable, just to measure the raw throughput of the async executor. Like, what is the minimal kind of thing it could do, or let's say the maximal kind of thing, right? Basically, you see here 4 nodes. They're all doing very well, and in total, this whole setup was doing close to 650,000 per minute, which is 11,500 something plus jobs per second. So this thing is fast, right? With decent hardware, again, decent hardware, decent network, this thing is fast if you give it enough threads. I think here I was using 128, 256. I mean, this is a report we're going to publish very soon publicly. Of course, you're going to say that nobody runs jobs that don't do anything. That's true. So we also benchmark if you have 15 seconds of wait time on average with a random distribution. This kind of similar setup went up to 400,000 jobs per minute. The point is not really the kind of numbers here. The point is really that this component, if you give it decent hardware, if you give it proper configuration, has good throughput, it has good scalability. But you need to kind of keep an eye on the metrics. And that is a good kind of introduction into where Filip will tell you all about these things.
Exactly. So basically, how do you know when you need to adapt, when you need to change certain properties, certain settings, right? And that's why it's really important to measure these things, right? So in order to measure these things, we are using Micrometer, which is basically a vendor-neutral application observability facade. A bit of a mouthful, but yeah, this is from their website, right? So what they offer basically is they offer a unified observability, which means that it has a single abstraction that can produce metrics, can produce tracing, logs, and more, right? And it holds, and you can think of it as SLF4J, but for observability, basically. And it has out-of-the-box support for different frameworks such as Spring, Halidon, Micronaut, and Quarker. So it is not only used in the Spring world, which Flowable is using, but it's basically the JVM standard, I would say, at the moment. Mm-hmm. And it has 2 parts. So one part is the micrometer metrics, basically. So these metrics offer an abstraction for dimensional metrics. This means that you can actually drill down in these metrics and drill down in time, drill down in bytes, in size, counts, and so on. So you can create timers, gauges, distribution summaries, and so on with this. And they offer support for publishing all these metrics to different services. And just to name a few, we have Azure Monitor, for example, if you're using Azure, CloudWatch, if you're using AWS, you can also use Elastic from Elasticsearch, OpenTelemetry, Prometheus, and so on. They're like, most likely, if there is a metric system, Micrometer supports and can push data to that system.
In fact, the screenshot I showed you before, they were from the observability numbers or metrics that I then pushed into Elasticsearch, onto which I put Kibana to make those pretty graphs that were in the slides, right? So it's a very flexible, cool system here.
Indeed. And apart from metrics, there is also micrometer tracing. So this offers distributed tracing. And what does this mean? This means that basically you can see how the data and how your requests are taking cross systems. So it means because your systems are not running it isolated, right? Let's say a Flowable async job starts and there is stuff like you do external calls. So you can see how much time is spent on those calls, right? This is so for people who know Spring Cloud Float. So this project, micrometer tracing, is a successor to this project. And it offers publishing these traces and spans via OpenZip in Brave or using the OpenTelemetry protocol. So, and most systems do support these 2 protocols. So yeah, the data is getting in there. And now let's see some metrics, right? So these are some metrics which are already available in Flowable Control. And these metrics are actually like Joram said, so we push these metrics to Elasticsearch, and then we use Elasticsearch and display them in control, right? And here we can see the async executor. We can see the queue, basically, so how many jobs are waiting to be executed, and we can see here that the queue is basically remains constantly full, which means that there is a lot of jobs that need to be executed, and there is difference.
Yeah, you want that thing to go down, right? I mean, the queue shouldn't be full all the time. It means that we're just skimping with the possibilities of the system right now. Yeah.
Yes, indeed. Yeah, and you can see there is a difference between like the async executor queue and the async queue, and the reason for that is because I configured it like that so we can have some different metrics, right? And we can also see the jobs that were executed. We also have a view where you can actually see the average execution time and the max execution time. And here, for example, like you can like look at the spikes and say, okay, why did this time go up, right? Or why did this average time went up, right? Is it expected that it goes up because you have some like slow jobs which you're expecting to run, or is it not expected, right? So you might need to react on that. And you also, the max execution time is, do you have a lot of executions which are like slow? Maybe you need to investigate why are they so slow, for example. And here we can see the async executor thread pool. So this means the active threads which are running jobs, right? So here we see that it's on 8, and it's basically that doesn't go down. This means that there's work happening, right? So it's busy. The executor is busy, so it cannot stop and it cannot reduce the
everything's
threads.
busy, right?
Exactly.
There's no extra threads available. It just is full all the time. You also want that to go down. Not all the time, but you want that to go down because otherwise it means your system is fully swamped with work. In this case, asynchronous jobs, right? It's executing. And by the way, one thing that I wanted to highlight here is that, and most people probably don't know that, even though it's in the documentation, but that you can change this dynamically at runtime. Meaning, if you see those problems with the threads and all of that, you can actually go into control and change the thread pool, change the queue sizes and all of that, and send that to all the nodes in your cluster, and basically update that at runtime, which is a very powerful feature. And I wanted to highlight that.
Yeah, and we've had this for a while actually, so it's not something new. I mean, we've had it for like few versions already. So you can already do this if you didn't know about it. And now here we have some more metrics. So here are just some like raw numbers for the amount of async jobs and history jobs that got executed. Then we have some new metrics coming in. So these metrics were all available, but now these one are upcoming metrics. So this is what you will be able to see in control now. So here we will be able to see the average execution time and maximum execution time of the service registry. This means that if you have, let's say, REST calls or script calls or DB services, maybe, you can actually see which ones are slow and what's happening in your system with this directly in control. And also, you can also see the raw numbers of how many times something has been executed here. So here are just the counts in the period that we've selected here. Next, which is quite important for Flowable, is the indexing. So the way that Flowable does indexing is using the bulk REST API from Elasticsearch, which means that we don't really send data one by one, but we send it in bulk to multiple indexes in one transaction. So with this here, we can actually see how big these requests are, right? So we can see the average size for the default Flowable bulk index, but also when you do the metrics, so we can all measure these things as well. And you can see the max size that's happening. So this is something that you might need to be aware and pay attention to. We're also storing the execution time, right? So here we would store the execution time for the searching queries, but also for the data, where basically when you persist the data, when you send it in bulk, right? And this might be indications. For example, here we can see some spikes, and need to investigate. Okay, why is that slow? Like, is your query maybe not optimized, or is there some other problem for that, right? So it's worth looking into it.
And when we have all these metrics, I mean, Filip was just telling you, you have these spikes you need to investigate, but of course, you're not going to come into the office in the morning and get your browser running and go and see, okay, what are the spikes today, right? Of course, in an ideal world, you would never have spikes. Everything would run smooth, but as we all know, world is not ideal. And also, I can't, be every morning and look at those spikes. I want to be alerted. I want to see somewhere central that these things need my attention. new feature, or we are adding a new feature into 3.17, which is incidents. It's meaning that we have all these metrics, all these numbers, observations, and you can define thresholds for these observations. You can say, okay, if the service calls take too much time, and you can define what is too much time in your setup, then if you cross that threshold, then basically go and create an incident where you can say, hey, we need to look into this problem perhaps, right? And I have a little demo I prepared for that I do want to show you. And let me swap now to my other screen. Here we go. All right, so this is Flowable Control, as you all know. And if I go now into the kind of system info section, you'll notice there is a new incident. And if I click on it, we've been creating a lot of incidents just for demo purposes. You can see that it's ordered by dates, by timestamp by default, because I want to see the latest kind of incidents. Of course, if I go to this page, if I filter here and I'm saying, for example, slow asynchronous jobs, I can have a look at that and click on any of them. Show me, okay, the execution time is higher than the configured out of time. It took like 0.6 seconds, which is not too crazy, but I mean, we configured it to create a lot of incidents, obviously. But the interesting part is I can actually look into the job that was responsible for it. I can see which process definition, process model was responsible for this, and which model element, right? The actual step BPMN was responsible for this. I can also see slow REST services, same story there. I can see this BPMN task 19 in the observability service responsible for this thing. I can see when my queue, where is this here? Like when my indexing queue is full, which I might need to then change more threads or higher queue size and things like that. So you get the idea of where we're going with this, right? Just looking at these graphs, which is impossible all the time. We're going to create incidents that will help you to create actions on top of this. All right, let's go back to the slides, because Filip is going to take us to the next level when we talk about metrics and about these kind of actionable things you can do.
Yeah, so basically we have some basic things in Flowable Control, right? And we have some incidents now that you can actually view and see what something happens in the system. However, most of our customers already have some infrastructure set up for monitoring their systems, right? And we even have a different infrastructure for our cloud where we're using different tools, and we'll go through some of those tools now. So here we will have, I'll show some things with Grafana, which is an open source analytics and monitoring solution that you can use to display some dashboards and drill down into metrics. And the system where these metrics are stored is Prometheus, which is basically a time series monitoring system, which allows you to query this data. Both of these systems offer some advanced alerting. So what this means that even if your Flowable instance goes down, it can still alert you that it went down. So you don't need Flowable to get the alert, right? And you can get an email for this. You do something in Slack, in Teams, or maybe even do calls like in the evening, send you an SMS or do a call. So like it's quite advanced what you can do with this. And on top of that, it also gives you access to view all the resources that you are having, right? So the database, the virtual machines, Elasticsearch, and you can actually track all the metrics and how they affect each other. So if the CPU goes up in Flowable, does it affect the database because it's processing a lot of data and things like this? So you can measure all these things. And now we'll see some statistics, some dashboards. So here is some really basic one, basically where we can see the uptime of the application. We can see the memory usage. We can see the CPU usage here, right? So just so you know what's happening in your system, right? Then we have some JVM statistics, such as, okay, how many threads are there in the JVM being executed? What's the actual memory right now in the heap, in non-heap? So like information that you need to know about. And then we have some statistics for the garbage collection. So especially like something on the right-hand side, how many times stop the world happened for garbage collection, which means that how many times everything was stopped and in order for garbage collection to run. When this is low like this in this picture is quite good, because it means that it's not blocking your throughput, right? If it's a lot of spikes, you might need to try to understand why that is happening and try to maybe even use a different garbage collection if it works better for you. And then we have the database connection pool here. So here you can see, okay, how many connections are currently active, how many are idle, how long a connection is being used, are they being used for a too long time, which means that, yeah, they're not being released, so your system can lag behind and things like this, right? So those were some standard Java and Spring metrics, but now we can also display some flowable metrics. So here we have again the async executor, and we have here even more drilled down the amount of active threads per executor. We have the content, we have the async history executor, and so on, like different ones. And you can even see the jobs and how they're getting executed basically based on the scope type, BPMN, CMN, or content. And we also, of course, have the new metrics, which is the service register, right? So here we can see the execution time again, how many executions have been happening. And this is even more drilled down, because here we can see, for example, that the REST is actually not one REST service, but actually two REST services with two different operations. And we can even see which operations are this and which services are happening here, right? And we can see here actually like this second REST service is actually slower, causing it like to be slower than the other one, right? And finally, we have the indexing as a dashboard. So the indexing here, we display the similar metrics. So like the bulk request size, the execution time, which allows you to basically drill down and see what's happening in your system.
Yeah.
And now, yeah.
Oh, sorry. There's another one. I was already excited to ask you, like, how can I get this right?
Yes. You have
talk about the tracing.
Yeah. So this is what I was hinting at one of the earlier slides, right? So here we have data pushed to Zipkin, which is an open, which is using the Brave protocol, and here we can see that an async job. So the async job starts. We have a database connection being opened. Transaction basically means we need to log this job. And then we go to the actual execution within the second transaction. And here we see that we have some database calls happening until we reach the REST service. And when we reach the REST service, we see that we wrap that around and we do an HTTP call to a third-party service. And this is the most interesting bit, at least for me. We can actually see how this like how this trace originated and where it's consuming the most time. And here we can see that it's actually taking around 250, 280 milliseconds on a different server, which is not running at Flowable. So they're independent servers, but because this information is given to that server and both servers are pushing this tracing data, we can see a graph like this. When that server is done, we see that Flowable finishes the job and we close the trace, right? So we can actually track all of this and find out like where is it slow and why is it slow, right?
And I think all of this is super cool, right, Filip? I think all these people, everybody likes pretty graphs. Yes. And the cool thing is you can already do this today. So all the stuff we showed, I mean, not the stuff that was stacked with 317, that's already being, there in all the previous versions of Flowable. Through the micrometer kind of metric system, you can already do all of these cool stuff. I think looking at the time to wrap up, we've covered a lot of grounds here. And basically, the story we wanted to bring you today, don't worry, right? If you want to scale out, we've got you covered. Flowable has the tools for you to get to the throughput you want. It also means you're doing something good. It means that your software is getting popular. So, about this. In the end, even if you're using models, processes, cases, DMN, you name it, it's still software. So regular software best practices, they still apply. These that apply them to whatever you do in Flowable. Apply the practices that we talked about today. And definitely the kind of thing we wanted to convey today is measure things we talked about and adapt, right? Use the tools available to you. Use a dedicated solution like Filip is showing you. And one promise from our side is that we will focus unrelented on performance, on throughput, as we've done over the last few years tremendously. And this is something, that we really actually like. So that being said, I think it's now time to go see what all the questions are that you've cooked up for us. And let's get Bert on the stage, shall we?
Thank you guys for the presentation, Filip and Joram. It was very interesting. We had some comments already coming in. And actually, some people already, some viewers actually helping each other and answering questions.
Even better.
Yeah. So, but we'll go through them anyway. I'll just go pretty chronologically here. So we had a first question coming in from Franklin Xu. And they're asking if it's doable and possible in Flowable to offload the history persistence. And they give an example of offloading the history auditing to an SQS queue that could be picked up by further down the line then.
Yeah. Yeah, I mean, the short answer is yes. Technologically, that's possible. I believe we actually did a prototype, or not more than a prototype, with this, where we actually serialize the data, set it into event, well, it doesn't really matter it's SQS or not, right? But yeah, that's totally possible. The only kind of thing you need to take into account is that, of course, you won't be able to kind of query your, let's say, live data together with your history data, depending on your needs, your dashboards you want to build. That might be needed. That's the thing you lose. But if that's not a problem, if you're, now thinking in classical data warehousing terms, yeah, fine. There's no problem. I would say get into contact with us and let's talk about it. Yeah.
Okay, cool. A second question then from Pitio, of the impact of long-running instances on performance. Mm-hmm. And he gives an example of a customer life cycle case that will be the whole time the customer is there, it will be active. And what will be the impact of that on performance?
Yeah, that's a good question.
Break it up into maybe multiple cases.
No, you shouldn't. Simply said, is when you are in a wait state, and this is a question I've been getting for the last 15 years pretty much. Yeah. And the reason is that there have been actual products in the orchestration space that actually kept everything in memory, and then you get this problem. Flowable doesn't. What we do when you go into a wait state, for example, if you have a case, you process some events, and then it waits until the user does something, right? This can be now, or it can take a week, it can take a year even, or even longer, it doesn't matter. But the point is, we persist it to the relational database, and it doesn't take up any system resources beyond disk space, obviously. So Flowable is in no means kind of constrained by the long-running kind of ET of the case or process. The only exception to that, if you have a long-running service task, imagine you've got something running for hours in your service task. Well, that will take up system resources when it's executing. But if it's in a wait state, no, Flowable just is twiddling its thumbs at that point.
Okay, cool. Then Deepak had some questions about variables and the best practices there when you have a process with multiple hierarchies and in and out parameters between these parent and child processes. Mm-hmm. So if there's any best practices there, and in the case of like big JSON variables, how they should maybe aggregate those variables to keep them as transient as possible to improve performance there.
Yeah. The question you want to take, Filip?
Yeah, so I can take this one. Yeah, so basically, so using in and out is actually a really good approach to like scoping all the variables that you have in your processes and cases, right? So this way that your child processes or cases will only don't use the root data, but they will only use the data that they need, which is passed into it, right? And aggregating it. So it really depends what you want to store in the index, right? So if you want to store something in a certain format in the index, so one way is like with the low code is you'll have to create that variable in the JSON, right? And store it also as a Flowable variable. But another approach that you could do is also we have different enhancers, which basically can enhance variable which just needs to be stored in the index. So from the existing data you're using Flowable, for example, like let's say you have like user ID and you want to store the first and the last name in the index, for example, what you can do is when the data getting indexed, you can actually enrich this indexing data and store the actual first and last name of the user into the index, for example. So that's an option that you could.
But it's an area which we're actively at this this kind of moment we're looking into to improve, because our customers often surprise us in good ways often. Is that sometimes it's people are storing a lot of things in these variables, and we're currently really looking at optimizing that and finding alternatives to be able to keep up. Because when we started with the first kind of engine that we built, people were putting like 5 to 10 variables in there, very small things. If you compare it to today, we've got hundreds of variables of huge JSONs and all of that. But in the end, that's kind of the message that I wanted to give today. It is just software engineering, right? If you write code, your variables will take memory, your variables will take disk space. These things, apply to a certain degree, even today, even with the fast machines that we have today. So it's not a free lunch, so to say. It's still need to think, but we're working on things to improve that because we heard that through various channels, and it is good. It's a good problem to have, right? That's what I keep saying.
Yes, indeed. Deepak had another question, and if I understand correctly, he's asking about asynchronous execution, and if there's not a lot of overhead associated with that, and if he should not be like careful with using a lot of stuff in asynchronous execution.
No, actually, it's one of the things that as we were saying, the default executor is like 8 threads, which is really low, and I really sometimes feel that we should make that higher, but then you need more connections. The thing is, if you think about it from a kind of architectural point of view, when you're doing an async job, most of the time, most people are waiting for I/O. For example, if you're doing an HTTP call to another system, REST or whatever you fancy, GraphQL, I don't really mind because it doesn't matter. But the point is, you're opening a TCP socket at that point, low level, and you're waiting. Your CPU is waiting for that interrupt to happen, and it will come at some point, right? 100 milliseconds later. But 100 milliseconds, remember that kind of the slide we had with the hand clap and the zucchini, right? 100 milliseconds is a huge amount of time for a CPU. So it can do a lot of work in that time when it gets that interrupt. And when it gets it, it will be able to process. The point is, that between those two events, you're just not doing anything. So you can modern processors are really good at interleaving these things easily, right? Now, the exception to that rule is if you have CPU-bound logic. The classic example being, for example, generating a PDF of 500 pages. That is pure CPU work. That's stuff that just hogs your CPU core, right? And it will continue to hog it until that CPU is done. There is no easy solution to that except adding more cores to your problem, right? But most people, 99 out of 100 cases, we're doing I/O intensive kind of logic rather than CPU intensive logic.
Okay. Then a question about, for example, when the async executor is stuck and jobs are stuck and not processing, they're asking how to troubleshoot. And of course, the metrics showed and alerts will already have a big impact on seeing what's going on. But if you have any more tips about how to troubleshoot this situation.
Do you have something to say, Flip? I can see it.
So apart from basically what we mentioned, right, where you can actually monitor how full your queue is, job queue is, how long they're taking, because one thing that can happen is you might have a lot of jobs, and let's say if each job is taking 1 minute, it's taking a lot of time to process the jobs, right? So that's a bit related to the previous one a bit. If your jobs are taking a long time to execute, then you just have one thread which is blocked and cannot execute other jobs. So that's why it might take, right? But another thing that you should also look into is, which we didn't mention here, but it's the dead letter jobs. So really often what can happen is, let's say if an async job failed 3 times, let's say it couldn't reach the third-party service, so like tried 3 times by default. Once that is done, there is a dead letter job created, and we no longer try to execute this job.
Yeah.
So I think that's one place where you can look into what's happening, and also look into in case your jobs are locked, for example, because what can happen is that if you're like, it happens with Kubernetes.
Yeah, exactly. I was going to say there is actually an unlock thread that runs behind the scenes. I don't think most people know this, but and it's a really high number. I think if it's over an hour that your job has been lying there, so to say, right? Then it gets unlocked, and another async executor in your cluster will pick it up. But that hour is a quite high setting, and perhaps if you don't like that, you need to put that lower that value. I think that's another thing that just popped into my mind.
All right, thank you. That was actually the last question we have time for right now. So Thank you to the viewers and their interesting questions, and Joram and Filip for presenting.